Something strange is stirring on the surface of the Sun. For weeks now, solar scientists have been watching in growing concern as sunspot activity intensifies. Faster, larger, and more unpredictable than expected. And now, it's official. NASA has confirmed that a massive solar storm is headed directly toward Earth in 2025. But this isn't just any ordinary solar flare. This one could rival or even exceed the power of the infamous Carrington event of 1859. A storm so powerful it set telegraph wires ablaze and lit up the skies with auroras as far south as the Caribbean. Imagine that kind of energy unleashed. In our modern world, where satellites, GPS, internet systems, and power grids are all tightly interwoven into our daily lives, the thought is chilling. What exactly is coming our way? How will it affect life on Earth, and what can we do to prepare? In this video, we'll explore the true nature of solar storms, how NASA detected this one, the worst-case scenarios scientists are bracing for, and the fascinating history of our planet's dance with solar fury. The Sun, our life-giving star, constant and familiar, has always been a subject of deep fascination and reverence. It's a yellow dwarf, about 4.6 billion years old, sitting roughly 93 million miles from Earth. It powers our climate, drives weather patterns, and sustains every living organism on our planet. But while the Sun may appear calm from here, it's actually a violent and dynamic sphere of nuclear fusion, constantly shifting and erupting with energy. Over the past year, astronomers have noticed something unusual. Using a combination of solar observatories, like NASA's Solar Dynamics Observatory and the European Space Agency's Solar Orbiter, scientists detected a dramatic uptick in solar activity. A cluster of sunspots, dark, magnetically unstable. Regions on the Sun's surface had begun to swell to sizes many times larger than Earth itself. But it wasn't just the size that raised alarms. These sunspots were releasing powerful flares and ejecting enormous clouds of charged particles, known as coronal mass ejections, at increasing frequency. What startled scientists most was the trajectory and timing of these ejections. Several of them were narrowly missing Earth. Then, just weeks ago, a series of instruments picked up a particularly massive ejection traveling at incredible speeds, fast enough to reach Earth in under 48 hours. It's rare to see this level of activity so early in the solar cycle. Some are calling it the most intense pattern of solar behavior we've seen in decades, perhaps even a century. It's a reminder that even our most familiar star can still surprise us. At the heart of this unfolding cosmic drama is the Sun's magnetic engine, a wildly complex system fueled by nuclear fusion. Deep in the Sun's core, hydrogen atoms are constantly being forced together under immense pressure and temperature, fusing to form helium and releasing vast amounts of energy in the process. This energy radiates outward through the solar layers until it bursts free from the surface as light, heat, and occasionally, something far more intense. The surface of the Sun isn't smooth or calm. It's a boiling sea of plasma, constantly twisted and contorted by the Sun's magnetic fields. Sometimes these magnetic lines snap and reconnect, releasing explosive energy in the form of solar flares. But the real danger lies in what often follows: coronal mass ejections, or CMEs. Imagine billions of tons of charged particles hurled into space, like a solar hurricane moving at millions of kilometers per hour. That's what NASA's Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe recently captured, one of the largest and fastest CMEs ever recorded. And this one is Earth-directed. These events aren't random. The Sun operates on roughly an 11-year solar cycle, moving from a quiet minimum to an active, chaotic maximum. Right now, we're heading into Solar Cycle 25's peak, and much faster than scientists had predicted. Some experts believe we're entering an unusually aggressive maximum, where solar storms could be stronger and more frequent than anything we've prepared for. To fully understand the threat, Scientists are using an arsenal of cutting-edge tools. Satellites like the Solar Orbiter track the shape and movement of the Sun's magnetic fields. Space-based X-ray and ultraviolet telescopes monitor flare intensity, and even Earth-based instruments, like magnetometers and radio telescopes, are picking up strange, high-frequency signals as the storm builds. The science is clear. We're watching a complex, high-energy chain reaction in real time, and the consequences of a direct hit could ripple across the planet in ways we haven't seen in modern history. What makes solar storms so uniquely urgent is that, unlike distant supernovae or ancient cosmic collisions, these events unfold in real time, on human timescales. When a coronal mass ejection is launched from the Sun, it can take anywhere from 15 to 72 hours to reach Earth, depending on its speed. The one now headed toward us? Scientists estimate it could arrive in as little as 36 to 48 hours. That means we're not talking about something that happened centuries ago. We're talking about an event already in motion, barreling toward us through the vacuum of space. This isn't a distant star whose light takes hundreds of years to reach us. This is our Sun, just 8 light minutes away, and that proximity means the effects, if and when they strike, will be immediate. Satellites could go dark. GPS systems might fail. Radio communications could be interrupted across entire continents. And in a dramatic twist, the skies could erupt in color as the charged particles slam into Earth's magnetic field and ignite auroras far beyond the polar regions. In extreme cases, auroras could be seen over cities like New York, London, or even northern India, dancing overhead like celestial fire. It could be one of the most spectacular atmospheric displays of our lifetime, or a planetary-scale electromagnetic disruption. Either way, the countdown has begun. The storm is coming, and we may only have hours before its arrival becomes undeniable. Imagine stepping outside and seeing the sky alive with color, not just the soft greens and purples of the usual northern lights, but blazing reds, electric, blues, and golden waves rolling overhead like a cosmic ocean. From rooftops in Tokyo to farms in rural Canada, from the deserts of Egypt to the beaches of Brazil, the night sky could erupt into a spectacle usually reserved for polar explorers. This isn't science fiction. It's what happens when a massive solar storm hits Earth's magnetosphere head-on. The charged particles from the coronal mass ejection slam into our planet's magnetic shield, compressing it, warping it, and sending waves of energy cascading into the upper atmosphere. At that moment, auroras become global. Even places that have never seen the northern lights could find themselves staring at a sky so bright it challenges the moon, casting shadows on the ground below. And it doesn't stop at beauty. People might look up and see brief flickers in satellite constellations, or lose mobile signals as GPS networks fail. In some areas, lights could go out, not because the power grid failed, but because transformers overloaded and shut down to protect themselves. It's a surreal mixture of awe and vulnerability. This could be one of the rarest skywatching events in human history, a shared cosmic moment for our entire species. A reminder that while we've reached for the stars, we're still tethered to the rhythms and dangers of our own brilliant, burning sun. For scientists, a massive solar storm isn't just a threat, it's a treasure trove of data. Every burst of radiation, every pulse of magnetism tells a deeper story about how our sun works and, by extension, how stars live and die across the cosmos. These energetic events let researchers study the solar magnetic field up close, test predictions about plasma behavior, and refine models that one day might help protect astronauts on deep space missions. It's like watching the heart of a star beat under stress, a rare opportunity to learn from the chaos. But there's something even grander at play. Though our sun isn't massive enough to explode in a supernova, its more violent cousins, like Antares, Betelgeuse, or Vivi Canis Majoris, end their lives in spectacular detonations that ripple through the galaxy. And it's in those cataclysmic deaths that the universe forges its most precious materials: gold, platinum, uranium, the very elements that make up our technology, our jewelry, even parts of our own bodies. This is the great cosmic recycling system. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of it was cooked in the heart of ancient stars and flung across the universe when they exploded. We are, quite literally, made of stardust. So when we study solar storms or gaze up at a sky filled with dancing auroras, we're not just witnessing a scientific event. We're seeing the echoes of creation itself. The sun is reminding us of where we came from and what connects us to the stars. While the words solar storm may sound alarming, it's important to remember: Earth is safe. Our planet is shielded by a strong magnetic field and a dense atmosphere that blocks harmful radiation from reaching the surface. Most of the effects will be high above us, in the ionosphere, where charged particles stir up auroras and, briefly, disrupt satellite signals. To us down here, it's more a light show than a threat. Even in the most extreme cases, these storms don't pose a direct danger to human health. What we're witnessing is more of a cosmic performance than a catastrophe. And thanks to advancements in monitoring, we now have global alert systems in place. Neutrino detectors, massive underground tanks filled with ultra-pure water, can detect tiny ghost-like particles that escape from the sun before the light does. That gives scientists a crucial early warning, sometimes by hours, to alert observatories and protect sensitive equipment. So, while this storm may stir the sky and spark imagination, you can rest easy. The science is watching. The systems are listening. And for most of us, it's an opportunity, not to worry, but to witness a rare and beautiful moment in cosmic history. We're witnessing the pulse of a living star, a reminder that even the most constant things in our lives, like the sun, are full of mystery and motion. This storm isn't just a burst of energy. It's a message across time, a whisper from our star that has burned for over 4.5 billion years. And while this particular event may pass without much damage, it leaves behind something deeper, a sense of scale, of fragility, of connection. To think that we can sit beneath this sky, looking up at dancing auroras born from the sun's fury, is to feel small and significant all at once. We are passengers on a pale blue dot, orbiting a star that gives us light, warmth, and occasionally a reminder of its immense power. Solar storms like this link us directly to the cycles that shape galaxies, the same forces that forge the elements in our bodies, the same patterns that guide the lives and deaths of stars. So the next time you glance at the sky, remember, it's not just a backdrop. It's alive. It speaks. And it's still full of secrets we've yet to uncover. Keep looking up, because the universe is watching, and its greatest wonders are often the ones we least expect. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. There's a whole universe out there, and together, we're just getting started.